Hello everyone and welcome back. So far we have seen a variety of methods that we can use them to create tensors. Hope they were helpful so far. So now we are going to talk about tensor attributes. Tensors have some attributes that they are useful and gives us very useful information. One of them is tensor shape. So let's create a tensor first. Let's call it T. We already know that we can create a tensor in different ways. So let's use the very basic method for that. Tensor, and we can pass an array 1, 2, 3 and 4, 5 and 6. This is a method that we already saw it, and now we want to know that we already know that this tensor has 2 rows and 3 columns, so it should be 2 by 3, the shape of the tensor, but we want to get from the attribute this shape, how to get that. So simply we can use an attribute called shape. So we can say that print t.shape and print it. So the size is 2 by 3. And also we can create a random tensor. Let's say trand. I'm using it just to practice a little bit. Torch dot rand, and we need to pass a size for that. So let's say 5 by 5, and let's say print t rand dot shape. Now we can get the shape as 5 by 5. All right. There is a method also in PyTorch that gives us the tensor shape. It's not an attribute, but because they do the same job, so I want to also introduce that. It's called size. So let's say for our tensor t we already created here, we can say print t dot size, but it's a function that shows that, so it should have this parentheses. Now both of them, let's comment this out and reprint it. So both of them shows the same shape. So you can use either shape attribute or this function. Another useful attribute is tensor type. So let's use our T tensor that we already created here without any data type, and let's get the data type of the tensor. So t dot d type, this is an attribute. So it says that the type is integer 64 or long. For that also we have a function that has the same functionality. So let's say print t dot type. It's a function. So these are the same data types. Integer 64 is the same as long tensor. So you can use either data type or d type or the type function. So here we reach to the point that this is the power of PyTorch, which using CPU or GPU, which it calls CUDA. So let's first print what device our code is running on. So to do that, let's say print, actually let's say this tensor is running either on CPU or GPU. So the same tensor t that we already created, dot device. This is another attribute. Now print it. It calls CPU. So let's check it on Google Cloud. So go to runtime, change runtime type here, and that's true because we used CPU. Now we can use GPU for that and save it. And again, if we run it, we again get it as CPU, or oh sorry, we need to run all of the cells. Yes, we again get CPU. The reason is we created the tensor and CPU, but we didn't move it to GPU. We have to do that. So here we can ask whether this device or our system uses CUDA or CPU. So we can define a variable called device, and we can say that device equals CUDA or GPU if torch dot CUDA dot is available. Is available. Otherwise, use CPU. So we can, with this function, with this line of code, we can tell that the device should be CUDA if available. If not, use CPU. Now we can transfer our tensor to CUDA. Have to run this one also, and also run this one. Now here it says that the device is CUDA, and we can also print the same attribute here. So print t dot device, and oh, okay, so we have to pass it to a new variable. Now it's CUDA. Another attribute is ndim, or the number of dimensions of a tensor. So let's bring the tensor that we already created here. and let's print n t dot ndim. So it says that it has 2 dimensions. As we can see, it's a 2-dimensional tensor. Now if we change it to a 3-dimensional tensor, we can have another tensor with 3 dimensions. So um, 10, 20, 30, and 40, 50, 60. Now here we can see this is a 3-dimensional tensor. There are other properties and attributes that tensor has, which we will see them in the next also sections that were very useful. One of them is requires grad. This is a Boolean attribute that tells the PyTorch that either it should keep track of the gradients of the tensor or not, which is very important feature for graph computation and also calculating the gradients. So this is very useful and we can use it pretty easy. So let's say tgrad, we can create a tensor torch dot tensor, and we can say that 1, 2, 3 and 4, 5, 6. So if we define a data type for that, d type, torch dot, because you know that gradient and also differentiation doesn't work on integer, it should be floating point. So float, let's first print it, print tgrad. It shows this is a float tensor. And now let's add requires grad to true, and let's run it. So this tensor has a grad functionality inside it, so it calculates the gradients whenever we need that. So whenever we want to use gradient and or differentiation in our program, we need to specify it whenever we create a tensor. And the grad also gives us the values. I do not talk about it right now because we have a section for that. So this is just showing that these are some of the attributes for tensors. So there are another attributes like grad fn or grad function, which stores the grad computation function. Also t layout or the tensor layout, the layout attribute, which indicates how a tensor is laid out in memory, which they are very less useful. There are some sort of other attributes that gives us a Boolean output, which is CUDA, is sparse, is leaf. So we will practice them whenever they are required in the very next videos. All right, thank you, and see you in the next video.